Welcome to lecture for research methods. I'll be talking about issues related to the measuring and manipulating of variables. So starting off, why do we care about how we manipulate and measure variables? Well, primarily because there is significant impact of the choices you make for how you're going to measure your variables and how you're going to manipulate your variables on the conclusions you can draw after analyzing the data that are generated by the study. Right? And we always talk about the conclusions we draw in terms of internal validity. So if we're doing an experiment, our confidence that the independent variable caused the difference in the dependent variable, our confidence in a cause-effect relationship, in large part is strongly influenced by the choices we make and how we measure our dependent variable and how we manipulate the independent variable. And then it also can have some important impact on the external validity of the study. In terms of the way we measure this thing, will that reflect differences in the world outside of this study? Right? The way we manipulated this variable, does that reflect this thing that you're trying to show, this variable out in the real world? Right? So which things, in terms of our choices, influence conclusions? A couple things. One, the reliability of the measures you use. Related to that would be the validity of the measure you use, and we can also apply the idea of validity to manipulating variables. The sensitivity of a measure to detect differences, and then the scale of measure. And we'll talk about each of these, and when we do so, we'll largely focus on the measurement of variables, but a lot of the ideas also apply to the manipulation of variables. And then at the end, we'll spend a little bit of time talking about, in particular, the manipulation of variables. But for the most part, we'll focus on measurement for now. So the first thing that influences the conclusions you can draw in terms of how you're measuring variables, the reliability of a measure. Right? So if we think about classical test theory, right? According to classical test theory, whenever you measure a behavior, and again that's what we measure in behavioral sciences, is behavior, you generate a score, and that score will reflect a combination of what the person's true score is and then some amount of measurement error. Right? There's a recognition that we can't typically, at least, measure behaviors perfectly. Right? And the idea being that, if we're asking about your attitude about something, or saying how fast you can hit a button, right? Usually we're not interested in how fast you can hit a button at this point in time. We're assuming that across all the times you would hit a button, there's some average number of how fast it would take you to hit that button, and that's your true score. And when we have you hit a button once, we'll get some measure of how fast you are, and it should be close to that average, but it might be a little different for a variety of reasons. Right? So there's some error in any kind of measurement. And so reliability then, you can look at this formula to get an idea of what it means. And basically it means that if we can measure a behavior without any error at all, it would be true score divided by true score, and it would be perfectly reliable. And as the amount of error in your measurement increases, then the denominator in this fraction increases, and the overall reliability goes down. Right? Okay, so there are at least two different types of error that we'll talk about. Bias and random error. And bias is systematic error. This is when some people are measured differently than others. Right? There's some variable that correlates with the error. And most commonly we worry about error in measurement being systematically different across levels of the independent variable, right? Where we treat one group one way and the other group another way, and we do that in terms of manipulating the independent variable, but there's something else about when we're measuring them that we're measuring something different in one group than in the other than what's being caused by the independent variable. So in that case, the error is correlated with the independent variable, and if that happens, it's going to make us draw the wrong conclusions, or could make us draw the wrong conclusions, right? Really, mislead us. But bias can also exist when measurement error correlates with some participant characteristic, right? Maybe in a study that included women and men, we weren't interested in gender differences per se, but maybe when we were measuring aggression, that women that demonstrated the same behaviors as men were given higher scores on a measure of aggression. Right? So again, that would be that would bias the scores and potentially screw up our conclusions. And then the other type of error would be random error, which is non-systematic error. So here, instead of just some individuals being measured differently than others, all or most individuals aren't measured with 100% accuracy. And these errors aren't correlated with any particular participant characteristic or the independent variable. They're not systematic across levels of the IV. Right? And random error typically won't make us think we had an effect when there wasn't, which bias might do that. But it may hide an effect. And we also often think about this kind of signal-to-noise ratio, where there's too much noise or static to detect the true signal that's there. So if there is a difference, there is an effect, but you can't see it because there's too much static. There's too many other differences going on in your two groups to see the difference that's being caused by the independent variable. Because when two groups differ, they'll differ because of the independent variable, if it has an effect, and they'll differ because of random stuff. Right? And if there's too much randomness, you won't see the effect of the independent variable. Okay. So we try to reduce random error, but we're really concerned about bias. In particular, if that type of bias is correlated with the independent variable, and when it is, we call that a confound variable. Right? So if you systematically treat two groups differently in some way other than the independent variable, then that's a confound. Okay? And we work really hard to eliminate those, and then we also after we make sure we get rid of that, we'll work on reducing the random error. Okay. So where did this error come from? Typically three places: from the participant, from the experimenter, and then from the measure itself. Okay, and we'll talk about each of those. But also, I want to say that fortunately, we do have some tools for estimating the amount of error. Statistical procedures developed to help us estimate the amount of error that may be distorting true scores. And most commonly, this involves calculating reliability coefficients that are based on either test-retest reliability or inter-rater reliability, or maybe both. And test-retest reliability is, as it should be clear from the name, you measure some behavior once and use that same measure again at some later point in time, and the two measures should be the same if the behavior is thought to be stable. Right? So you're measuring something that people should, maybe trait where they shouldn't change across time, or you're measuring it in such a short period of time they shouldn't have changed from point A to point B, then the performance at time 1 should be highly correlated with performance on time 2. If it is, we've got a reliable measure. The thing about an unreliable measure, the example I always use, is if you have a scale at home and you get on and it tells you you weigh 140 pounds, and you get off and you get back on and it says you weigh 150 pounds, and in that intervening time of maybe 10 minutes you didn't gain 10 pounds, right? You didn't eat 10 plates of fajitas. Then your scale is unreliable. It's not giving you the same score over time. Even though the thing that it's measuring didn't change, the score is changing, indicating there's lots of error in there. It's unreliable. Right? And then inter-rater reliability, most often we use whenever our measurement involves some observation of a behavior. So we may be observing a kid on a playground and looking for instances of aggression. So count how many times the kid is aggressive, and you'll operationally define what is aggression for your raters. So if a child makes physical contact with another child, that results in the other child falling down, screaming, or whatever, you have some clear definition of what they're looking for, and then you're going to have them rate the number of times, and then you're going to see, okay, did they all agree? And if they did, then the way you're measuring it and the rules you came up with for operationally defining aggression have good reliability. If not, if everybody kind of comes up with different numbers, then your rules are probably too vague, and you don't have enough structure in there, and you have poor inter-rater reliability, and then you can't, you won't be sure what the number means. Okay, well, this kid was real aggressive. Well, I thought they were aggressive, but I didn't. Okay, well, who's right? There's too much error in the measurement to be confident about what the number means, what the data generated by the measure means. Okay. So we want good test-retest and inter-rater reliability. In terms of how high the coefficients need to be, at least 0.7 is kind of a rule of thumb, and that's a rule of thumb agreed upon by a bunch of researchers. But there's no law that says it has to be above 0.7. But as a general rule, that's what people go by, and you prefer it to be higher than that, 0.8, 0.9, somewhere in that range. Okay, so let's go back to the sources of error and the things that detract from reliability. One, the participant. Right? We talk about what participants do in responding to measures, in exhibiting behaviors that we're trying to record that can lead to or contribute to more error in their score and disguise their true score. So we're not quite sure that the number means what we think it means, because we may get different numbers different times or across different situations, because there's something going on other than the true score. Right? And one of the things that can contribute to error from the participant is actually an interaction of the participant and the experimental situation, and that's demand characteristics. Demand characteristics are hints that participants pick up on, and they can either be in the materials you give them or from the experimenters themselves, but something about what they're doing where they pick up some hint about what responses are expected of them, kind of what they think the study is about. If they get some idea from it, and oh, you're supposed to answer this way. And sometimes the experimenter may unintentionally create demand characteristics. Sometimes participants will see demand characteristics where none really are, just because they want to be helpful, and so they're trying to figure, okay, what are they looking for? I think they're trying to ask about this. I'm going to answer it this way, rather than how they really feel, think, or behave. Right? And then you can take steps to deal with these demand characteristics. Primarily by two ways: unobtrusive measurement or disguising your measure. And both of these methods raise some ethical concerns about clients being fully informed about their participation. And you've got to balance, okay, how much can I kind of mislead participants, and how important is this research? Right. But when it comes to unobtrusive measurement, obviously that's about they don't know that they're being studied, so spying on them, which is a little shady. It's actually easier to do now that you can snoop on people online. Or the other way to do it that's a little less sneaky is to just do archival research. So you look at people's existing records so that they can't change the behavior. The behavior's already been recorded. Right? Another approach would be to disguise your measure. And this generally involves trying to mislead them about what you're measuring. And clever researchers come up with all kinds of ways of doing this. You might use, a fake title for your study. Maybe you want to look at attitudes toward women, and you have them rate a series of pictures of women on a variety of characteristics. But you tell them, oh, this is a study about the impact of technology on motivation, right? Because you're having them rate the stuff on a computer, right? And you may even throw some in experiences in the study that aren't relevant to the hypothesis, right? Like ask them to rate their experience using a mouse on a keyboard, right? And you don't care about that question, but you put that question in there to disguise what you're looking at. Oh, they're interested in the mouse and technology, and they're trying to see if I'm going to get bored on this computer. But you're not. You're looking at the other stuff. Right? So you give kind of a red herring, as it were, some sort of distractor in there to disguise your measurement. Which, depending on how clever you are and how good it is, it may or may not work. But then, obviously, you are essentially lying to participants, which we'll talk more about ethics, about the importance of debriefing whenever you do that, and also the importance of being able to justify deception in research. Okay. Another source of error would be the social desirability bias. This is when participants distort their responses in an effort to look good, right? So oftentimes when we ask people about attitudes, that if they harbor any negative attitudes, say racist attitudes or homophobic attitudes, they won't really tell us, because they know what the appropriate answer is, what the socially appropriate, socially desirable response is, and they tell us that rather than how they really feel. And there's a couple ways to deal with this. You can try to give them options that don't have overly positive or negative connotations, right? So you don't ask, how much do you hate black people? Because most people, hopefully, wouldn't answer that, very much, right? So you have to be a little more subtle and a little more clever in how you ask questions. You don't ask loaded questions. To what degree do you think that dangerous criminals should be allowed to kill again versus being executed? Okay, there's not they can't. There's not much room to answer that in terms of social desirability. You can make their responses anonymous, and this helps reduce the impact of social desirability, but it doesn't go away. Even when you tell people that nobody's going to look at their answers, oftentimes either they don't believe you that nobody's going to look, or they still have this kind of Jiminy Cricket on their shoulder, saying, this conscience saying, well, I really think this, but that's just wrong to say it. I don't want to put on paper. Even if nobody knows that I said it, I don't want people to know that somebody thinks this way. Right? So you can eliminate the social desirability effect by using anonymous reporting, but it helps. And typically, what researchers do when this is a concern is they measure social desirability. And there's a couple of scales out there that are designed to measure the tendency for someone to represent themselves in a more positive light than is warranted, or in a socially desirable way. And then they'll see if that measure correlates with the measure of the dependent variable. The idea being, okay, well, if people are trying to respond to kind of social desirability, and that's what's making my measure look this way, then those people who really try hard to look good will score differently on my DV than people who don't worry about trying to look good. And now I'll be able to see a difference. And so researchers say, oh, and the DV was not correlated with social desirability, measure social desirability, and so it was not thought to be a factor. Right? So that's one of the most common ways to deal with that problem. And then the other source of error is just inconstancy in mistakes. Right? People are inconsistent. Right? Give me a survey question today, and I might answer, on a scale of 1 to 5, how do you feel? I'm going to answer a 3 today and a 4 tomorrow. And probably my answer would vary across situations, what day you ask me, around some number, maybe 3.5, maybe 3, maybe 4, somewhere close to how I'm answering any of those days. And that's probably my true score. The point is there is some randomness associated with measuring dynamic entities, which people are very dynamic. Right? We are not exactly the same from day to day or from moment to moment. So there's some inconsistency, and then also people might just make mistakes. Someone might intend to respond to a question, very true, but accidentally mark not at all true, and so that's contribute error to their score and make it the measure look less reliable. The best way to deal with this is to try to get a large sample of behavior, right? Because you recognize that a single behavior probably won't reliably indicate what you're trying to measure. So if I'm trying to ask somebody about their attitudes about guns on campus, I won't ask them one question, because after one question and they make a mistake answering it, or they're not quite paying attention, then I'm really misled. If I ask them 10 questions on it and they mistakenly answer one messed up, right, but the other 9 are okay, I've taken an average of those 10 questions, I'll still get a pretty good idea of their actual attitude. There'll be some error in it, but not as much if I just ask that one question. So however you're measuring behavior, you want as large a sample of behavior as possible. Just like we want a large sample of people, we also want large samples of behavior when trying to measure things, especially constructs. Right? Other sources of error, the experimenters, which experimenters are the people who administer and score the measure. And one thing you have to look out for are expectancy effects, and this is when experimenters intentionally or more often unintentionally skew the results by treating participants differently based on what condition they're in, or scoring their responses differently. So you're going through and you had a bunch of people fill out surveys, and you have options 1, 2, 3, and 4, and they circled somewhere between 3 and 4. And for your hypothesis to be supported, they need to have circled a 4 would be better for your hypothesis than a 3. And you might go, that looks pretty close to a 4, and that's not really a 3. Right? So there's this experimenter bias coming in. And then also just kind of subtly treating people differently can influence measurement. And then just like participants, experimenters can make mistakes. Just write down the wrong number when scoring a measure or when giving a measure, not giving it the same way to everybody. oh, I forgot to tell that group that they could erase answers if they wanted, but I told the other group, oh well, it's going to be fine. Right? You can't do that. You can't make those kind of mistakes. And so to deal with these things, a couple things you might do. One would be obviously standardization of your measurement approach. So have everybody experience the same things in the same order when measuring your variables, and then also standardize the scoring. Which standardized scoring is especially important if you're collecting observational data, right? Like we talked about, if you're collecting data about kids playing on a playground, you have to have a very clear operational definition and very clear rules about how behaviors will be recorded, which behaviors will be recorded, and the frequency, the duration, all that stuff you have to outline very clearly in order to have a reliable measure. Because if you don't have clear rules for measuring behavior, then error is going to creep in. It leaves room for bias and also leaves room for random error. Okay, so standardization is important. The other thing you can do to especially deal with expectancy effects is to use some sort of blinding or masking technique. Right? This is where the people who interact with the participants and or are scoring their responses don't know what condition they're in. Right? They don't know if this is the group that got the active level of the input variable, or if they got the placebo level. Right? And it's possible you might even have people scoring your data that don't even know what the study's about. And I just want you to enter these numbers off of this paper into this computer. That way, when there's that dot that's between a 3 and a 4, they've got no reason whatsoever to say, oh, that looks more like a 4 or 3. They'll just make an objective call. It's closer to one or the other, or it's in the middle. I'm going to call it 3.5. Right? So taking away the knowledge of what condition people in or what the study is about from people who interact with the study, which means if you're the experimenter, you may have to hire somebody, a graduate student usually, to help you run the study, and you don't tell them yet what the study is about or who's getting what levels of the independent variable. And then last, the measure itself may contribute to error. And this can come whenever the measure includes vague instructions, right? Some participant errors may be due to poorly worded instructions regarding how to complete the measure. Related to that, poorly designed measure, where it's not clear how or where to indicate your answers. And this usually has to do with formatting issues, to where people don't know if they should circle a number or draw a mark through a line. They aren't sure how to respond to the stimuli that you're presenting with them, and that can contribute to error and reduce the reliability of a measurement approach. So beyond reliability, is validity, right? And when we talk about validity in measurement, really we're talking about construct validity, right? And this comes into play whenever the things that we're directly measuring are not the things we're actually interested in. Rather, we're interested in certain constructs, love, self-esteem, determination, and what we're measuring is thought to reflect those constructs, right? Sometimes you may really be interested in certain behaviors, right? Usually not in psychology. Usually we're interested in behaviors because we think they indicate something. Even if it's something that seems very applied, like number of cigarettes you smoked today, and we have this kind of smoking cessation program. But even number of cigarettes you smoked isn't exactly what we're looking. We're looking at cessation of smoking, and that's kind of a larger idea than just the number of cigarettes, because we might also be interested in, okay, you didn't smoke any cigarettes, but do you still crave them? Did you do anything else? Smoke a pipe, chew tobacco, right? We're interested in this kind of bigger picture than just some specific behavior or behaviors. So we're usually interested in these constructs, which are constructed ideas like love, self-esteem, determination, depression. Right? So construct validity then is the degree to which differences on the measure reflect meaningful differences in the construct they're intended to measure. Okay? A shorter way of saying it is, are you measuring what you say you're measuring? Right? So if you have a measure of determination, right? So you have some task maybe, and you make it difficult or impossible to complete the task. Right? And you're going to measure how long participants spend trying to complete this task, trying to put this puzzle together that has a missing piece or that doesn't fit together. Are you measuring determination, or are you measuring frustration? Right? So you have to think about, okay, how's this construct related to this other construct, and which one am I measuring? Okay. And it takes quite a bit of reflective thought usually, and then some other steps to figure that out. But you want to think carefully about the construct you're trying to measure and how that can be represented in the real world. Okay? So how does validity relate to reliability? Reliability is necessary but not sufficient for validity. Right? So to have a measure that has good validity, strong construct validity, a prerequisite is high reliability. Right? Because you can't be confident that you're measuring what you think you're measuring if the number's coming out different all the time. Right? But you could have reliability without any validity whatsoever. Right? You could go home and get on your scale. Every day you get on your scale, it tells you that you weigh 10 pounds. And no matter, day after day, 10 pounds. That is a perfectly reliable scale. Right? Test reduced reliability, perfect. But probably not valid. You probably don't weigh 10 pounds. I hope you don't. But if it's not reliable, so it tells you 10 pounds today, 100 pounds the next day, 140 the next day, and let's say you weigh 140. It got it right once, but it's still not a valid measure because it doesn't have reliability, because we don't know if it would have, when we give you the measure, is it going to get it right? We don't know. Could get lucky. If you're not sure, then you can't be confident in the validity. Right? So reliability is required, but not sufficient for validity. Okay. So measurement validity, construct validity, in many ways is related to internal validity, which remember, internal validity is about our ability to draw conclusions about the cause-effect relationships we're trying to study. And then there are other aspects that are more relevant to degrees to which our findings can be generalized to individuals in settings that aren't identical to those we study, which is external validity. So first we'll talk about those things that, and they relate to both, but more directly relate to internal validity, and that would be content validity, right? Which content validity is the extent to which items are relevant and representative of the construct for a particular assessment purpose. Right? So if I think about depression, I want to measure this construct of depressive experience. So I want all the questions I ask or all the observations I make, however I'm gathering data, to be relevant to depression. So not asking people how much money do you have in the bank. Right? That's not relevant to depression. There may be some correlation between income and depression, but just because they're correlated doesn't mean that it's relevant. That's not part of what depression is. Right? So that's irrelevant. So I want to ask the only stuff that is relevant. And that's part of content validity. Everything in there is relevant to what you're trying to measure. So I'm going to have in there some question about depressed mood, degree to which your mood is depressed. Right? But I can't just have that. Right? I can't just say how depressed is your mood, how sad is your mood, how much time do you spend feeling blue, and I could even do some reverse word stuff. How often are you do you feel joyful? And I would just reverse score that, right, to where I want people on my measurement of depression, I want them to answer, no, I'm never joyful. Right? So that's absence of joy is related to depression, so that's relevant. But I also want it to be fully representative of the construct. That means having enough items, enough questions, enough observations to represent the fullness of the construct. And if I think about depression, one way to think about it, from kind of a diagnostic point of view, at least, would be that it involves affective symptoms, which I've been talking about, kind of the depressed mood. It also may involve anhedonia, right? So the loss of interest or pleasure in previously pleasurable events. So I want to ask about, the things that you used to enjoy doing. Do you still do those? Right? But it also involves cognitive symptoms, right? Guilt, worry, suicidal thoughts, and then it also physiological symptoms, changes in sleep or appetite. And so if I really want a measure that has good content validity of the full construct of depression, I've got to ask about all that stuff. But again, that's where you have to decide what you want to measure. Maybe you are interested in measuring that large construct of depression. If so, you can ask a lot of questions. But maybe you're interested in depressed mood, and that's your construct. So you just have to clarify what it is you're measuring, what it is you're studying, and make sure whenever you talk about your results later on, that it's the terms you're using are justified by your measures, right? So if I'm going to say this intervention contributed to a reduction in depression, I better have measured everything about depression. If I didn't, I may just be able to say this intervention led to a reduction in depressed mood, and then that's valid if I measured depressed mood. So pay attention to how you're measuring stuff, and then remember that whenever you're talking about your findings. Okay. But again, for somebody to have good content validity, everything has to be relevant that you're asking, and then you have to ask enough stuff to cover the whole breadth of the construct. And then you also look at internal consistency, which is often talked about related to regarding reliability, because you calculate it a lot like you do some reliability coefficients, but it's really more an indicator of validity. Right? Whenever you have multiple questions or observations that are supposed to tap the same construct, right? So again, I'm trying to get all this stuff to assess one thing. If it is a unidimensional construct, right? So there, all these things, all these questions relate to this one construct, then they should be internally consistent. Right? So the idea being that if you're measuring anger, and one of your participants is really angry, then she should look angry on all the questions. Right? If there's one or two questions, the chances where she doesn't seem so angry, then you don't have as much internal consistency, right? So everything going in the same direction. And somebody who's not angry at all, they should look not angry on every question or every observation. Okay. And you have ways of measuring that, which typically include calculating a Cronbach's alpha or or inner item correlations. I won't go into a long story now, but better to look at inner item correlations than just Cronbach's alpha, because Cronbach's alpha is very sensitive to the number of items. If you have a lot of items, it's going to make that number larger, even if they're not that internally consistent. Okay. Okay, so we want to look at internal consistency, and then the other big thing is convergent and discriminant validity, sometimes also referred to as divergent validity. This is looking at how your measure, however you're measuring something, how it relates to other measures of other constructs. Okay, so your measure should converge with other measures of the same construct. Right? So if you have some measure of depression, and somebody else has a measure of depression, the people that take your measure and take their measure, they should correlate. Somebody who looks really depressed in your measure should look really depressed on their measure. Somebody who looks really happy in your measure should look really happy on their measure. Right? If so, you've got good convergent validity. Right? And then they should also converge to some degree with measures of similar constructs, but not too much. Right? So if we think about anxiety and depression being related constructs, then how people perform on a measure of depression should have a moderate correlation with somebody else's measure of anxiety, right? But it shouldn't be perfectly correlated. And so here we have kind of a combination of convergent and discriminant validity, where we want them to converge, we want them to be somewhat alike, but not too alike. We still want to be able to discriminate between people who are depressed, purely depressed, and purely anxious. Right? So discriminant validity is about your measure not correlating with measures of constructs that it shouldn't be related to. Right? So your measure of depression should correlate with the Beck Depression Inventory. It should, really well. It should probably moderately correlate with scores on the Beck Anxiety Inventory, but then it should not have a significant correlation with the Eating Disorder Inventory. If it does, then the thinking is, well, maybe you're measuring eating behaviors more than you're measuring depression. It's not a pure measure of depression. Okay. So all those things relate to your ability to draw cause and effect conclusions, because it's about, am I really measuring what I say I'm measuring? And there's other aspects of validity, measurement validity, construct validity, that relate to external and ecological validity. And external validity, remember, is about being able to generalize conclusions you draw at the end of the study. And then ecological validity is a related concept, but it's a little different. It's the degree to which your procedures and your measure, we're talking about measurement here especially, reflect the real world. Right? So if I'm trying to study marital satisfaction, and I could give a paper and pencil measure of marital satisfaction, that has less ecological validity than if I measured their marital satisfaction by installing video cameras in their homes and finding and coming up with some way of rating the number and quality of their behavioral interactions at home, right? Because if I'm actually seeing how they are at home, that looks more like what I'm trying to measure in terms of their marital satisfaction at home. It has higher ecological validity than a paper and pencil measure in the lab. But just because something has high ecological validity doesn't mean that it will necessarily have high external validity. And that may be confusing because, well, it should generalize. Well, it'll generalize to whatever kind of ecology that you're simulating. Right? So if I put cameras in these people's homes, then whatever I find about my intervention affecting marital satisfaction, I can be confident that it's true for them in their home, but it still doesn't mean that it will be true for other people in other homes, right? So ecological validity isn't sufficient for external validity, but it is often important. Okay. Okay. So in terms of trying to measure and even increase your external validity, ecological validity, things to look at are one would be criterion validity, right? Which is looking at how scores on how you're measuring something, relate to observable outcomes, as opposed to other measures of constructs. So if we're seeing how our stuff relates to other measures of constructs, we're talking about convergent and discriminant validity. If we're looking at how our measure relates to observable outcomes, criterion, things in the real world and not other measures, recidivism rate, number of times you got pulled over by the cops for DWI. So looking at these outcomes rather than measures of constructs, that's criterion validity. And we can talk about predictive and concurrent validity. Not a big difference there. Predictive is obviously I measure it now and I'm looking to predict some future behavior. So I'm going to measure your intelligence now, and then look at how my measure of intelligence did in predicting your academic success. So I measure it before you go to college, and then I correlate that with GPA after your 4th year to look at the criterion validity of my measure of intelligence. Right? I can also use concurrent validity, where I measure intelligence, and then I go and look at, well, what are your grades right now? And those should be related if I have good criterion validity. Again, this contributes to kind of external validity because it kind of tells you, is your measure related to important real-world things? Right. So if I have some measure of marital satisfaction, one thing I might look at in terms of criterion validity is people who score high on marital satisfaction, 5 years later, are they still married, or are they divorced? And if everybody who has high satisfaction was married, people who had low satisfaction were divorced, then I may be doing a really good job of measuring marital satisfaction. There's some evidence for criterion validity, and then I feel better about, okay, if I have this study that's increasing marital satisfaction, then again the goal usually is beyond marital satisfaction. It's for increasing marital stability, relationship stability, whatever. Then I'm more confident that I'm doing what I'm trying to do. Related to that is discriminative validity, which sounds very much like discriminant validity, but is a little different. It's related to criterion validity. Can the measure be used to reliably discriminate between groups who should differ on the construct being measured? Right. So, if I have my depression measure, do people that have been diagnosed with major depressive disorder, do they score higher on it than a group of people that are maybe depressed and at a funeral but don't have major depressive disorder? Right. My measure, according to at least one theoretical approach, should be able to distinguish between those two groups. That if my measure is kind of measuring clinical depression, then I should be able to tell one group from the other, even though they may be similar. If I'm really measuring what I'm saying I'm measuring, I should be able to tell these groups apart. Okay. Another thing that can influence conclusions you can draw is the sensitivity of your measurement approach, and this is just the degree to which your measure is able to detect differences among participants on the construct you're interested in. Right? So very much related to construct validity. If two people are only slightly different, Can you tell on your measure? If so, it's highly sensitive. If you can kind of tell big differences but not small differences, it's not as sensitive. Right? So its relation to reliability and validity, you can't have specificity without good reliability and validity. Right? Reliability and validity will limit the amount of sensitivity of your measure, but they're not sufficient. Something that's reliable and valid won't necessarily be sensitive. So the other thing you need to be mindful of is how the measure is designed and how the data will be collected. And the thing we look at is there potential for capturing variability in scores? Right? One kind of simple consideration is when you are gathering data and you're making some decision about how to assign numbers to it, are you looking at it in terms of a dichotomous variable or a continuous variable? And dichotomous is yes, no, true, false, present or absent. So they were angry, they weren't angry. Okay. And if you use a dichotomy, you'll have poor sensitivity, right? Because angry, not angry. What if somebody's slightly angrier than somebody else? Can you tell? No, because all I know is angry, not angry. So this is kind of just common sense. Obviously, if you have a continuous variable where you're measuring at all possible points of anger, then you'll have a maximally sensitive instrument. And so anywhere in between is kind of where your sensitivity is going to fall. So maybe you don't have a fully continuous variable, but you have multiple points on a scale. So rather than yes, no, it's were they a 1, a 2, a 3, a 4, or a 5? Okay, so that's more sensitive than the dichotomy. If I've got a 9-point scale, that's more sensitive than a 5-point scale. So the number of points on your scale, the number of different gradations of the behavior that you can measure contributes to, or the way to think about it, limits the amount of sensitivity you have in terms of being able to discern differences in participants on the construct being measured. Okay. The other thing to be thinking about are looking out for floor and ceiling effects, right? So and when people are going to respond to your measure in your sample, will people top out or bottom out, right? Topping out is when you have a ceiling effect. Bottoming out is when you always have a floor effect. So that when they give if they give the highest response possible, but you give an IQ test and they get everything right, and somebody else gets everything right, but one of them is smarter than the other. But you can't tell that one person's smarter than the other because they both hit the ceiling. You can't capture more differences in the construct above where your measure ends. And the other thing would be the floor effect. If they both get everything wrong and solve the questions, but one is less intelligent than the other, you can't tell that difference because of this floor effect. Right? They can't respond any lower, even though they have less of the construct than the other person. So you want to design your measure in such a way that you can make sure and have kind of more than you think people would be able to say, and also less than most people would be able to say of whatever you're measuring. Okay. And then the last thing to think about in terms of sensitivity is mutability. Right? This is that consider whether the behavior you're measuring is liable to change, if it's mutable or immutable, right? And is it liable to change given what you've chosen to do to the people, given your independent variable? Some behaviors and characteristics are more volatile, more mutable, more responsive to inputs than others. You might be able to, if you do something to people, give them some information or show them some experience, you might get them to move on some measures of attitudes about spirituality. How likely are to donate money to your church today? We can probably show people things, tell people things to move that, at least temporarily, and they may revert back to pre-existing attitudes, but in the short term, we can move that. But if we do a similar kind of thing, and we ask people about their core beliefs, to what degree do you now question the existence of God? We're probably not going to see much movement on those things. So some behaviors, some attitudes, we can move, at least temporarily. Others, less likely. So you have to think, okay, will this thing change? Can it be manipulated? And then, given what I've chosen to do I think I'll be able to see differences if there is an effect? Okay. The last thing I'll talk about in terms of influencing the conclusions we can make based on measurement is the scale of measure. And this is the scale of measure used to record your data, right? So if we look at it's kind of this hierarchical scale. Starting at the bottom, we have variables measured on a nominal scale. This is when it's used to describe categorical variables, right? So red, blue, yellow. Even if it's a number, the numbers aren't meaningfully different. Uniform numbers on a basketball team. Number 5 isn't less than number 7. Okay. So when you use a nominal scale, the values mean something, but they only differ in quality, not quantity. Right? So if I'm going to say, okay, you're this and you're this, I can tell if people. Now I've done stuff to people in your you're passed out and you're awake. And we have some drug study. That would be on a nominal scale. But I can't say that you're more awake than you are passed out. It's kind of like one way to think about it. A dichotomy is one type of nominal scale, but there could be others. So I'm asking people. We shouldn't use nominal scales too much, but you can't do much with it because all you can tell is differences in people, and you don't know about who's more than who or how much different they are, just that they are different. Right? So usually we use something above the nominal scale, possibly at the ordinal level. This is whenever the outcomes of observations can be ordered along some continuum. So now there's a difference when you get this number, there's a difference, and that difference also implies order. Right, so somebody running a race, somebody comes in first, second, and third. Right, whoever came in first was faster than whoever came in second or third. So that you can have more of something or less of something than somebody else. Right? But we still don't have all the information we could have. Right, because if we have a race and they finish first, second, and third, and first and second place were separated by 1/10 of a second, and then second and third place were separated by another 30 minutes. Well, those aren't equal distances between places, right? So the interval between first and second, the interval between second and third are not the same. And we don't have equal intervals. We're missing a big part of the picture. Oh, you came in first, you came in second, you came in third. Oh, third, you were so close. No, it was actually 30 minutes later. We don't know that because we didn't measure it that way. So ordinal can be useful, but it's still missing some of the information that might be helpful. So often we try to measure at least at the interval level. And now we have order. We obviously have difference. It's kind of assumed. But we've added order, and now we've added the amount of difference. And we do that because we have equal intervals between values. Right? So now you can talk about how much more or less of a quality or a construct one outcome has than the other. So if we're measuring aggression, right, we've come up with some way to measure that, and somebody is a 5 and somebody else is a 4 and somebody else is a 3. Okay, well the 5 is 1 more than the 4 and the 4 is 1 more than the 3. Right? So the 5 and the 4 and the 4 and the 3, they're equally different from each other. And we like to have that, and oftentimes our statistical procedures require that the data be on an interval scale of measure, and sometimes we act as if they are, and we just kind of hope that that's true. And I say this typically about when we have Likert type scales. We say, okay, on a scale of 1 to 7, indicate how much you agree or disagree with the following statement. Right, and you have some statements. The school's mascot should be a water buffalo. 1, not at all agree. 2 or 3, somewhat agree. 5, completely agree. Right? And we assume that the distance between numbers is psychologically equal. That if you say the distance between not at all agree and somewhat agree is the same as the distance between somewhat agree and completely agree, and that may or may not be true. Right? We assume it is. We act as if it is, but that might be a false assumption that may lead to misinterpretation of data. So pay attention to that and make sure that you have good intervals, and look at kind of the established way of creating items, especially if you're doing Likert type scales, and you're more likely to get truly interval data, but it's not guaranteed. And then the kind of the holy grail of measurement, which I don't think anybody rarely gets, I would say, would be measuring at a ratio scale level of measurement, where you have order and amount of difference, and also degree of difference. So now, because we have a true zero, we can talk about ratios, about how much more one is than the other in terms of it's twice as much, 3 times as much, a third as much. But that only happens if your measure can truly indicate and accurately indicate the absence of a construct. And that's incredibly rare for it to happen. And so my advice to you is, whenever you're measuring something, assume that it's not ratio. And when you assume that, that means don't ever say, when interpreting results, that participants scored twice as high on this than this, or these participants showed twice as much aggression than these participants. Because you can only make those kind of statements if you measured on a ratio scale, and it's very rare that we can make those statements. Okay, so you talk about more, you talk about less if you've done interval, but don't go into quantifying in terms of ratios of one score to another. Okay, a couple different approaches to measurement, just kind of some brief stuff. This is by no means an exhaustive discussion. But typically we'll measure behavior using one of 3 approaches, right? We'll ask people about someone's behavior, theirs or somebody else's. We'll measure physiological phenomenon, or we'll directly observe the behavior. So whenever we do asking people about behavior, let's talk about self-report or other report. Typically we'll use something like interviews, or maybe surveys or questionnaires. And ideally, if you're doing this, you're using something that's been established. It's got established psychometric properties, so you know how its reliability and validity estimates, at least with other populations. And then, best case scenario, there's some normative comparison group available, right? And standardized rules for administration scoring. That way, you can say, okay, they scored a 10 on this, and out of this huge group of people that took it already, only 2% of that group of people scored this low. That means that this score is significant, right? So it kind of helps you give meaning to scores whenever you can compare it to a bunch of other people's scores. And usually we see that with measures of intelligence and achievement, but then also the major personality inventories, the PAI, the MMPI. They're standardized in norm referenced materials. And then some of the other measures that have been around for a long time, measures of psychopathology, also have norm references where you can say, okay, this score is clinically significant, so they're reporting more eating disordered behaviors than what we typically see in a community sample, and they're also reporting way above average what we see in a typical eating disorder clinic. And you can make those kind of statements if you use those kind of instruments rather than trying to create your own. But whenever we ask people to report on their behavior or someone else's, there are always concerns about the accuracy of those reports. Because sometimes participants are unable to know the answer. So they don't know it, they have never known it, and they will never know it, just because it's beyond their understanding. So asking them maybe to comment on why they do something. Which of the following best describes your reasons for engaging in arguments with your spouse? They may not have that awareness, right? So the true answer to that question, they don't know, and they don't know that it's because of all these other interacting variables. They're not psychologists; they don't know that. It may also be they can't remember the answer. We ask people to recall retrospective data. We worry about the validity of that and the reliability of that. When you were a child, how often were you spanked? Okay, because we know memory is not like plugging in a DVD and hitting rewind, whenever we're recalling information from our past, our ability to retrieve information and how it comes out and how it's translated when we pull it back to the present time is influenced by everything that's happened since then, and it's influenced by our current state of being, state of mind, state of thinking, state of inebriation, all those things. So when asking people about memories, we're real cautious about what that means. And then sometimes they may know the answer, but they don't want to tell us the answer. Either because maybe it's shameful, embarrassing. Maybe they want to distort their response to look better. Maybe they want to distort their response to look worse. Maybe we're asking about somebody else and they're mad at that person, and so their response is distorted by their angry feelings, or distorted by their loving feelings. So they're going to, oh no, they never do that. They're wonderful. Right? So there are concerns about the accuracy of self-reports and other reports. So usually when we talk about it, at that level. So instead of saying, this intervention led to a reduction in depressive symptoms. If we only measured it via self-report, we need to say this intervention was associated with a reduction in self-reported symptoms. Right? But if I measure self-report stuff, I've got some other measurement too, some clinicians' ratings, maybe some objective observation. Then I can be more confident in making a more general statement, a reduction in depressive symptoms, rather than put that limiting statement on there, self-reported, right, or other reported. If you only measure it that way, be careful how you talk about it. Okay. Physiological measures we sometimes use, heart rate, galvanic skin response, and some of the newer stuff using in psychopathology research, looking at EEGs, MRIs, things like that. And we often use those because they're hard to fake. Not impossible to influence, but they're hard to purposefully fake. Unfortunately, so that's kind of a plus. Unfortunately, there's also substantial ambiguity in interpreting the results. Many physical phenomena, like sweating, are related to multiple psychological constructs. So if somebody is sweating and we're measuring galvanic skin response, is it because they're anxious about lying? Are they anxious about being tested? Are they just really angry right now? What is it that's contributing to this physiological response? We can't always be sure. And then the other approach would be to do direct observation, right? And this is, for many people, the gold standard, because it takes away some of the participant bias, but also introduces more opportunities for experimenter bias. And so you want to be really careful to have systematic observation, to have lots of rules about how things are going to be observed, clearly defining what it is that will be observed. And then when you talk about your outcomes, about what you measured, make sure that you're not overstating what you found based on how you measured it. Okay, so being very systematic, being very careful, and then also getting as large a sample of I don't know what I was thinking. As large a sample of behaviors. To take out the word population there. As large a sample of I guess you put in the word the, as large a sample of the population or their population of behaviors. So again, if we're trying to look at some kid being aggressive, he has some population of aggressive behaviors and non-aggressive behaviors. All his behaviors that he ever exhibits and ever will exhibit on the playground. And we go observe one day, that's a small sample of the population of behaviors. So we're going to want to get as big a sample as possible to be confident that we're making clear statements about the actual population of behaviors, about how he really is or she really is, rather than just we caught that person on a bad day. Right? Okay. So now we'll come to the manipulation of variables, and you can apply much of what we've talked about with regard to the measurement of variables to the manipulation of variables. Right? You want to be confident that your approach to measuring some variable accurately and faithfully assesses differences in that variable. And you likewise want to be confident that what you do to or with participants to manipulate the independent variable accurately and faithfully represents different levels of that variable. Right? So imagine you wanted to look at the effect of depressed mood on memory. You might use some technique to create a negative mood in people I want to induce negative mood. It's impossible to be 100% sure that what I do to them will cause the exact change in mood that I'm interested in, right? So there's room for error. Right? So let's look at some ways that we can reduce that error. Obviously, as we've talked about before, standardization of the manipulation is important. This is about having good experimental procedures where you have very clear rules about what's going to happen to participants, and you make sure that the rules are followed. Right? So, and the big idea here is that as much as possible, when you have participants at different levels of an independent variable, so you're in the depressed mood group, you're in the happy group, they should have identical experiences with the exception of the independent variable. Right? So again, if I'm maybe showing a movie to manipulate mood, and one movie to depress, one to make you happy, well, how else might those movies be different other than the impact on their mood? Right? If one's longer than the other, shorter than the other, if one requires more thinking on the part of people watching it, there are all kinds of ideas, all kinds of things that can creep in to influence differences in groups and make their experiences not the same. So you got to be careful with that. Again, make the experience as identical as possible, except for the thing you're trying to manipulate. And again, I'm trying to manipulate mood. I can't do it directly, so I'm going to have to do something else. I've got to be very careful about what it is I do to them to make sure that it's faithfully and accurately only manipulating mood and not manipulating something else. Okay. The other thing, which we've already kind of talked about, is blinding. So blinding the experimenter to what condition people are in. Because, again, experimenters, even the most ethical and well-meaning experimenters, can inadvertently treat people differently based on what condition they're in. And there's some really interesting studies done where they found this, where they got a bunch of genetically identical rats, which used a lot in science, and they sent them to the different research labs to tell them, okay, here's these things are to be used to do. We're doing an experimental study on these rats and running mazes, and we're going to send you we bred two different groups of rats. One are bred to be super smart, and the other are bred to be super dumb. Right? And they sent to different rats different places, but they lied. All the rats were exactly the same. But lo and behold, the super smart rats ran faster, solve the maze faster than the dumb rats. Right? And that's because there's these expectancy effects. They expect them to do well, and so they'll treat them differently, they'll score them differently, and they'll create those differences. So as much as possible, we want the people who are interacting with the participants to not know what condition they're in, to avoid this experimenter bias and expectancy effects. And then another thing we might use are our placebo groups, right? Because if we do something to one group and nothing to the other group, so to manipulate an independent variable, we do something to you and we do nothing to you, essentially we're creating demand characteristics, right? The participants that getting nothing, they know they're getting nothing and that they're not supposed to get better or change or what have you. Right? One solution is to use kind of a placebo to help disguise which level of independent variable a participant is receiving. And a placebo is usually typically thought of in terms of pills, right? You get a pill that's an inert substance, like a sugar pill. But the idea can be applied to other manipulations as well. But sometimes it's not exactly straightforward. Oh, they got a placebo, they didn't. Because one thing you have to look out for, there still may be demand characteristics. If the placebo group gets an inert pill, they'll likely have few side effects. They'll still have some because there's a placebo effect on side effects. But the drug group may genuinely have real side effects, and this will serve as a cue to them that they're not in the placebo group. I really got the drug because I'm feeling really nauseous. I'm supposed to get better. I think I am getting better. Right? So you can't fully account for that with placebo groups, but it does help. Okay? The other thing you can do when manipulating variables to make sure that you're doing the right thing is use a manipulation check. Right? And this is a technique for measuring whether or not participants are able to discern differences in the independent variable when it's presented at different levels. Right? So often done as part of a pilot study, which a pilot study is just a small study you do, usually with a small group of participants who won't be part of your big study that you write up later. But you do it before the big one to work out the kinks. And one of the kinks is you want to make sure that you're effectively manipulating your IV. Right? And you aren't looking at differences on the dependent variable, but on some other variable that directly assesses whether the IV is being effectively manipulated. So with my mood and memory study, I'm looking at the effect of mood on memory. I'm not going to show people a depressed movie and see how it affects their memory in my pilot study. I'm going to show them a depressing movie, and I'm going to ask them to report their mood. I want to make sure that I can depress these people. If I am, then I'm effectively manipulating my mood variable. Right? And maybe I have my that group and my happy group, and I'll measure mood, and I want the two groups to differ only on mood. I don't want them to differ on other stuff except for maybe memory. So anything not related to my dependent variable, I just want to make sure that there's a difference in mood, and I'm not manipulating other things. One group's not more frustrated than the other. Last, there are different types of manipulation, which really breaks down into two broad categories. One would be an instructional manipulation, which is the most common approach, giving oral or written instructions that differ across groups. It's easy to do, but participants may misunderstand your directions, and or they may be influenced by demand characteristics, because it's often easier in this type of study to figure out what the study is about. So it's most often used, and it's easy, but it is subject to some participant bias disrupting your results. So they're really kind of creative researchers do environmental manipulations, and this is where you can do some fun stuff, right? Like you go in an elevator and stand facing the rear, in either wearing an NFL jersey or wearing a business suit, and seeing if people will react differently, if they'll turn around and face the back too. You can do cool stuff like that. Like on the social side, people have all kinds of fun manipulations. Environmental manipulation, when you do stuff differently than people, it can be harder to standardize than an instructional manipulation, but certainly not impossible. You just have to be pay attention to standardization a little more. It's not as easy as, okay, this form looks like this form. You got to pay attention to everything that you're doing and account for all the possible things that might go on different than the IV. Okay. And then one type of environmental manipulation that merits more discussion is the use of confederates. Right? And confederates are people who are involved in the study, but they're pretending to be participants. Example: I did some research when I was an undergrad looking at male answer syndrome, the tendency for men to answer questions regardless of whether or not they actually knew the answer. Which, interesting, we named it masculine answer syndrome, because it had to do more with your masculinity than biological sex. Anyway, I was a Confederate, and 3 people went in the room, me and 2 other participants, and they thought I was a participant, and we were told by this other experimenter, okay, I want the 3 of you to look over this list of questions and discuss the answers, and we're interested in looking at group dynamics or something like that. And there were questions like, why can't penguins fly, and I don't know, all kinds of random questions that didn't have kind of clear answers, at least none that we knew. And I had a script that I had memorized where I was supposed to say certain things. And so, what I said was different in some groups than in others. So in one group, I would try to answer questions, right, and make up kind of BS answers. And then when working with other participants, I would say, geez, I don't know. And we're looking at the difference in interacting with somebody who is engaging in kind of this man syndrome than somebody who doesn't. So obviously this can be trickier to standardize. It takes a good bit of training and practice when using confederates to make sure that they're doing the same things with different people other than the IV. And there are also some concerns about misleading people, because the general public's trust in psychology and psychologists in general probably started eroding in the 70s and 80s because of all the lying that psychologists did, especially on college campuses, to the point where now when people come into studies, they expect you to be lying to them because we did so much lying in the past. People read about the studies where people lied to them, in the Milgram study and things like that. So there are some ethical issues, and it can be tricky, but it can also be a powerful way to manipulate a variable. And you can do some other things that makes it easier to disguise what you're looking at, more so than if you're just kind of this paper and pencil type manipulation. Okay, summing up, the main things we talk about here are that the choices you make about how to measure variables and how to manipulate variables affect the conclusions you can draw at the end of the study. And that's what we're always worried about, is the internal validity and external validity of the findings. So the choices in designing affect those things. And we've talked about different ways that they do. It's important to be systematic, organized, methodical when designing a study. You got to think about all these different things and look out for all these different pitfalls for errors. But the other big thing, and I think what makes behavioral science potentially exciting, is there's a real opportunity here for some methodological creativity. Right? There are all these potential problems related to the error in measurement and manipulation, but there you can come up with some really clever solutions to these problems. And if you read the research, especially outside of the clinical area in social psych, IO, you'll see some examples of really creative thinking and ways of getting at the core idea of a construct without asking it in ways that it's easy to detect what you're doing. Okay, that's it for now. Take care.